So in this situation, we have a drug testing scenario. 98% of the time the drug test is accurate, which means that if you are a drug user, then 98% of the time you will be shown to be a drug user. If you're not a drug user, then 98% of the time you'll be shown to not be a drug user. But 2% of the time, drug users will be shown to not be drug users, and non-drug users will be shown to be drug users this 2% of the time. And also, let's just imagine, so we can think about this problem, let's imagine that 5% of the people in this situation actually engage in drug use. So the question is, if someone tests positive, how likely is it, what's the probability, that the person has actually engaged in drug use? Well, here's how we might start. You don't have to start it this way, but here's how I'm going to start it. I'm going to first of all imagine that inside this box here, this rectangular shape here, that there's a bazillion people. And of those bazillion people, 5% of them are drug users, according to our situation. Which means 95% of the people are non-drug users. Now, suppose these people take a drug test. Let's start with the drug users. So of this 5% of the bazillion people, 98% of the time, they will be found to be drug users, so, and 2% of the time not. So let's just, for sake of discussion, let's say that's 2% right here. So this is 2% of the time that these drug users will test negative. So this is 2%. And then let's say this is the 98%, again, of just that left side, the 5% of drug users. So 98% of the time, those drug users will be tested positive. So 2% of the 5% are drug users but are tested negative. 98% of the 5% are drug users and are indeed tested positive. So let's think about this again in terms of numbers. So I said there's a bazillion, just to get us to be thinking about it, but maybe for the sake of discussion, let's say it was 1,000. Let's say there's 1,000 people. 5% of 1,000, or 0.05 times 1,000, are drug users. I believe that comes out to be 50. So we have 50 drug users. Now, of the 50 drug users, 2% of them are going to be tested negative, and 98% of them are going to be tested positive. So let's see what those numbers come out to be. I'm just pushing some buttons here and making mistakes. Let me try that again. So, of the 50 people, 98% of them are going to be tested positive. So 0.98 times 50, let me try that again. Oh yeah, it does come out to be 49. And of those 50 people, 2% of them will turn out to be not drug users, but that comes out to be 1. Alright, so that's some information we will use later. Now on the non-drug user side, kind of similarly, I'm just focusing on the right side now, the 95% side. And let me kind of shade it in. I'm focusing here right now. So I'm going to split that up into 2%. So 2% of these people are not drug users, but they're going to be tested positive. Remember, 2% of the time the test is wrong. Well, if they're non-drug users, the test would be wrong if they came out positive. And 98% of the time, the test will come out negative as it should. If they're non-drug users, the test should come out to be negative 98% of the time. So again, just putting some numbers to it, on that right side, that shaded side, 95% of the bazillion, or let's just say 1,000 people, that would be 950 people, 950 people do not use drugs. And of those 950 people, 98% of the time, it'll come out the way it should. They'll come out negative. So if you took 98%, 0.98 times 950, you get 931. So 931 of our non-drug users will be tested correctly, but 2% of them, and 2% of 950 is 19. So 19 of them will be tested incorrectly. So let me just label this again. These are drug users. These are non-drug users. Alright, so maybe you want to even label inside of your boxes what everything is. So the 2% of the drug users who test negative is one of them. The 5% of the drug users who test positive and are positive are 49 of them, 50 total. The 2% of the non-drug users who test positive, 19 people. Now that's probably the scary part. There's 19 people who are said, like, hey, I didn't do it. And then 95% of the people are non-drug users and indeed test negative. That's 931 people. Alright, so far I've not answered the question. The question says, if someone tests positive. Now look at the picture. How many people tested positive? The 49 people from the drug user population tested positive, and the 19 people from the non-drug user population tested positive. That's a total of 49 plus 19. I think that's 68 positive tests. So 68 people tested positive. The question is, if someone tests positive, okay, 68 people tested positive, how likely is it that that person has actually engaged in drug use? So the idea is this. Think about probability. Put those 68 people in a paper bag, and then reach in and grab one of the people and find out if they're a drug user or not. They're actually a drug user. Well, there's 49 such people out of the 68 possible. So this is where some of you didn't quite catch on to the idea. It says, if someone tests positive, 68 people tested positive. How likely is it that the person has actually engaged in drug use? 49 people actually engaged in drug use and tested positive. So 49 68ths, and I believe if you check the computations there, that comes out to be just about 72%. So if you were to test or to randomly select a positive tester, there's a 72% chance that they will actually be a drug user, which means there's a 28% chance that they would not be a drug user. So 28% of the people who test positive for drugs are not drug users. And then that's where you might have the discussion about the controversy about whether or not this is accurate. Some of you got into the 2% versus 98%. That sounds good, and I agree. That's an argument that people make. But another argument that people make is this one here. It's only a 72% of the people who tested positive. 72% of them are actually drug users, and 28% are not. And that's where the controversy resides.